Good day, viewers. You are welcome to today's math class. Now, today we'll be talking about this topic called surd. I know that most of us have heard about it, but you are still finding this difficult to solve. Now, but before I talk about the definition of surd or what surd is all about, I want you to know what irrational number is. So irrational numbers are numbers that cannot be expressed in the form a over b because where b is not equal to 0. Now, also another definition of irrational numbers are numbers that does not have a limit value. For instance, 2, 5, 3, 5 and so on. And if you look at all these numbers, the thing here is that they are the root of non-perfect square, which share the same derivation as what we call surd. Don't forget perfect square. For example, 4, 9, 16 and so on. Those are what we call perfect square because you can easily find the root of it. But when we are talking about irrational numbers, our root of non-perfect square like 2 is 3, and their value does not have an end. Because when you type in your calculator the root of 2, you are going to have 1.14 and so on. If you look at pi is defined as approximately 3.14 and so on. So they have no end value. And so you can just say that surd are the root of non-perfect square. Non-perfect square are like numbers 2, 3, 5. So these are surd, these are surd, these are surd. The root of non-perfect square. That's the definition of surd. Now let's move to the basic rule of the operation of surd. Starting with addition and subtraction. So now, in the addition part, the rule states that, for instance, we have the root of a plus the root of b. This is telling us that this is not equal to root a plus root b. Note that this is not equal to each other in surd. And also for the one of subtraction, when you have root a minus root b, this is not equal to root a minus b. This is not equal to each other. Now let's solve question under it. For instance, you have root 80 plus the root of 20 minus the root of 45. So how do you simplify this? Firstly, you can still break this down. And how do we break this down? We are going to look for a perfect square that you are going to multiply with a number that is going to give you this value inside the root. Now, if you look at example 1, this is under addition and subtraction. Now, if you look at 80, you can express it as 16 multiplied by 5 because 16 is a perfect square, right? You can easily look for the root of 16. So just say that 16 multiplied by 5 because this is going to give us 80. And here we are going to have 4 multiplied by 5. 4 is a perfect square, and you can easily find, since it's a perfect square, you can find the root, right? And here we can express this as 9 multiplied by 5. Now, what is the root of 16? The root of 16 is 4. So what you are left with is root 5. Plus the root of 2 here is 4 here rather is 2. So you are left with root 5. And here the root of 9 is 3. So we have minus 3 root 5. Now, you can see both are having root 5, root 5, root 5. Therefore, you can add up and subtract. So, first, let's add root 4 root 5 plus 2 root 5. That is going to give us 6 root 5 minus 3 root 5. Now, you can now subtract because they are having like terms. Yes? So, we have 6 minus 3 root 5. And this is equal to 3 root 5, which is our answer. I hope you understand. So let me rub up this side. Now let's talk about the under multiplication and division. So the rule states that you have, for instance, a multiplied by root b. This is equals to root a multiplied by root b. And for the division, you have root a divided by b. This is equals to root a over root b. Now let's solve the question under this. For instance, now you have root 2 multiplied by root 3. You can write this as root 2 multiplied by 3, which is equals to root 6. This is true for all sorts, because of the rule stated that when you have root a multiplied by root b, it's equals to root a multiplied by b. Right? Okay, for instance, now you have 2 root 3 multiplied by root 3. You rewrite this as 2, you have this 2 here, and when you multiply it and this multiply each other, you are going to have 3 multiplied by 3, which is equals to 2 root 3 multiplied by 3 is 9, right? And the root of 9 is 3. So you have 2 root 3. Now, let's look at the division part. For instance, you have the root of 35 divided by the root of 5. You can rewrite this by saying the root of 35 over 5, right? And you can still write this by saying the root of 7. 35 divided by 5 is 7, right? But we can't simplify this further, we just do the answer like this form. So we have root 7. Now I hope you have understand this basic rules of sum under addition, subtraction, multiplication, and division. Now we are going to talk on rationalization. Rationalization of sums. Now, let's first solve one with a single base. For instance, now you have 2 root 10 over, let's say, root 5. Example 1 under this. How do you simplify this? To rationalize, first thing, why do you rationalize? For instance, now, if you look at this question, we are having root 5 as the denominator. Therefore, we are going to rationalize it because we want to we want to remove this root 5 from the base. We want it to be just a number. We don't want any surd at the base of this fraction. That's why we rationalize. Now to rationalize this denominator, why this denominator? We are going to multiply the denominator by the numerator and the denominator itself. That's how to rationalize. For instance, you have a over root b. To rationalize this, it will be a multiplied by root b divided by root b multiplied by root b. So you are going to multiply the numerator and denominator by the denominator. So now let's rationalize this. You have 2 root 10 divided by root 5. Multiplying both the numerator and denominator by root 5, right? So now, using the basic rules of surd under multiplication, right? You can see it clearly. So we have 2 root 10 multiplied by 5 divided by root 5 multiplied by 5. So here now we have root 10 multiplied by 5 is 50. So we have 2 multiplied by 50 divided by 5 multiplied by 5 is 25. So we have the root of 25. So we can still simplify this further by saying 25 multiplied by 2. Since 25 is a perfect square, right? So we have 2 root 25 multiplied by 2 over the root of 25 is 5, right? So we just like it here. So we have divided by root divided by 5. Is equals to what is the root of 25? 5, right? So when the 5 come out, the 5 is going to multiply 2. So let me write it out for better understanding. So we are left with 2 divided by 5. So since I've written the root of this out, which is 5. This 5 can cancel out this, right? Since we are dividing. So we are left with 2 root 2. This is our final answer. I hope you guys understand. It's not hard at all. To rationalize, since you have a surd form at the denominator, that's when you are going to rationalize. And to rationalize, you are going to multiply the denominator by the numerator and the denominator itself. Now, let me do one more side. So now, sometimes you may have a bigger question, like for instance now, but let me just explain. When you have 2 plus root 3 as a surd, this is a surd, right? This is a surd. Now the conjugate of this is going to be 2 minus root 3. The conjugate. Now, this is going to be the conjugate. How do we get the conjugate? If the sign here is positive, the conjugate sign will be negative. And if the sign here is, maybe for instance, you have 3 minus 5, the sign here is negative, the one here is going to be what? Positive. Now, let's simplify the question. Let's solve the question. For instance, now, we have 2 root 10 over 2 plus root 3. This is why we are going to apply this. Don't forget example 2. Now, don't forget the denominator, we have a surd as the denominator, so we are going to rationalize. And to rationalize, we are going to multiply the conjugate of the denominator by the numerator and the denominator. You can see that this is different from this. This one we are only having a we are only having it in a single form. But here now it's not in a single form, right? So what we are going to do is that we are going to multiply the numerator plus root 3. We are going to multiply the numerator by the conjugate of the denominator. So what is the conjugate of the denominator? Will be, we are going to change this sign here, which is positive to negative. So we are going to have 2 minus root 3. We are going to multiply the numerator by it, and also the denominator by 2 minus root 3. Now, I want you to recall this. We are going to be reading this. We call it difference of 2 squared. Difference of 2 squared. For instance, you have a squared minus b squared. This is equals to a minus b multiplied by a plus b. Don't forget, we are going to apply it here now. So here we are going to have, to multiply this, don't forget expansion. We are going to multiply this by this, and we are also going to multiply it by root 3. Now let's start. 2 root 10 multiplied by 2 is going to be 2 multiplied by 2 root 10, right? And also 2 root 10 multiplied by root 3 is going to be minus 2 root 10 multiplied by 3. Look at it where we use the multiplication rule here, we apply it here. Now divided by, when you now look at this denominator that we are about to multiply together, when you compare it to this is the same thing as what we are seeing here is the difference of 2 squared, right? And the difference of 2 squared says that when you have a case, similar case like this, we can rewrite it in this form. It is equal to this form. That is, here now, if you look at this 2 as A and look at this root 3 as B, they are similar to this, right? We can just write it in this form by saying 2 raised to the power of 2 minus root 3 raised to the power of 2. When you expand this, you are still going to get the same result. So instead of expanding, why don't you do it in this form so that you will be faster with your solution, right? Now we are going to have to multiply by 2 to be 4 root 10. minus here 10 multiplied by 3 is 30, right? So we have 2 root 30 divided by here 2 raised to the power of 2 is 4 minus roots can cancel as a power, so we have minus 3 is equals to. Can we simplify this further? No, we can't simplify this further. So we just leave it like that by saying 4 minus 3 is 1, right? So we are going to have 4 root 10 minus 2 root 30 divided by 1. It's still going to give you this. Or you can leave your answer in the form. Since 2 is common, you can just leave it out 2 into brackets. 4 divided by 2 is going to give us 2, right? So we are going to have 2 root 10. 2 divided by 2 is going to give us 1. So 1 multiplied by 2 is 3. So there's an invisible one in front of 30 already. So you can leave your answer in this 2 form. Anyhow you leave your answer, you are correct. So that's our answer to this question. Now let me look for more questions. Another question here, we have simplified. You call it example 3. Simplify root 75 minus 3 over root 10 root 3 plus 1. Leaving your answer in the form a plus b root c, where a, b, c are rational numbers. So that's how we should give our answer in this form. So now let's solve this problem. Now we go again. We have root 3 root 75 minus 3 over root 3 plus 1. Now what is the conjugate of this form? This sum at the denominator is going to be root 3 minus 1 over root 3 minus 1. So we are going to multiply the denominator and numerator by the conjugate of the denominator, right? Now let's expand. Don't forget here we just apply the difference of 2 squared formula by saying root 3 squared minus 1 squared. And at the numerator we are going to simplify. First thing, you have root 75. You can express 75 as the multiplication of this. You just say root 75 multiplied by 3. It's going to give us root 75 multiplied by 3. Yes, and also root 75 multiplied by minus 1. It's going to give us minus root 75. After multiplying both by root 75, we are now going to move here, which is minus 3. Minus 3 multiplied by root 3 is going to give us minus 3 root 3. You must learn how to expand. Also, we are going to multiply minus 3 with minus 1. So, minus 3 multiplied by minus 1 is going to give us plus 3. Now, you can still simplify 75 further by saying 25 times 3. Because 25 times 3 can give us 75, and 25 is a perfect square, right? So we can just say that 25 times 3 times 3. Because we have 3 here already. Minus here we have 25 times 3. And here we have minus 3 plus 3. All divided by. Root cancel out the power, we are going to have 3. Then since this cancel each other, minus 1 squared is 1, right? Minus 1. So here we have the root of 25 to be 5, right? Divided by 3 multiplied by 3 is 9, right? Minus the root of 25 is going to give us 5. So we have 5 root 3 minus 3 root 3 plus 3, all divided by 2. So here now the root of 9 is going to give us 3. So we have 5 times 3 minus, here we have, these are similar terms, they both have 3. So we can add them up by saying minus 5 minus 3 is going to give us minus 8 root 3 plus 3, all divided by 2. So we can say that 15, this is going to give us 15, right? 15 plus 3 is 18. 18 minus 8 root 3, all divided by 2. So now 18 divided by 2 is going to give us, or let me write it down as 18 divided by 2 minus 8 root 3 divided by 2. Now 18 divided by 2 is going to give me what? 9 minus 8 divided by 2 is going to give me what? 4 root 3. Now let's compare this to this. Let me write it out. We get our final answer as 9 minus 4 root 3. So the question says we should write it in this form. So we can write it in that form by saying 9 plus into brackets minus 4 root 3. You get? Now comparing these two together, the value of A is going to be 9. The value of B is going to be minus 4. While the value of C is going to be 3. So we have done and dusted. That is our values for A, B, C. Respectively. Guys, I hope you really understand this class. And I hope when you come across any question on Surds, you will be able to solve it as fast as possible. Thank you for watching. Please don't forget to like, share, and subscribe to my channel. Thank you. Bye.